In this video, I'm going to cover a few problems from the homework assignment. I'm going to start with number 18, which is from chapter 7.2 about arithmetic sequences and series. And the key thing for these is that whatever term we start with, each consecutive term increases by the same exact amount. So in this example I pulled up, we start with 5, each term gets 4 larger, and so on. So for number 18, we're trying to find what that first term is, and it gives us S12, which is the sum of the first 12 terms, and also what the 12th term is. And so we're going to have to do a little backwards working here to get the solution, and we can use one of the formulas from the chapter. So here we are in 7.2, and we got these formulas that relate how the first term, whatever nth term is, and the sum of those first n terms. So there's two different formulas to use depending on what information you have. This one's going to be easiest for this problem because we have all but one piece, so we'll use a little algebra to solve for that missing piece. So we have the sum of the first 12 terms, and we have the 12th term. All we're missing is what A1 is. So to work it out here, plug in our values. The sum of the first 12 terms is negative 110. We're adding 12 terms together, so 12 divided by 2 is 6. This is what we don't know, the first term of the series. And then we know what the 12th term is. It's negative 18. So we're going to need to multiply everything by 6 there and distribute on the right side. So 6 times A1, and then negative 18 times 6 is negative 108. So plus negative 108. I could have just wrote minus 108, but that's another way to write it. So I am going to change it to minus 108 because that makes it easier in my mind to do the algebra. So plus negative 108, which is minus 108. So then to get this part alone, we add 108 to both sides. So over here, that's going to leave us with a negative 2. I don't know why I wrote O2, but that's fine. Negative 2. And then so to solve and get A1 by itself, we divide both sides by the 6. So negative 2 divided by 6 would be negative 2 divided by 6. And over here, we have just A1. And you can reduce that then to the lowest terms as a fraction. That would be negative 1/3. And that is our final answer. And for the second half of the problem, we are figuring out what D is, which is the difference between each of our consecutive terms. A formula that connects all the different pieces we have is listed in the book right next to that first formula we copied over. And so we'll use that formula and just plug in what we have. So we have our sum of the first 12. 12 divided by 2 is 6. 2 times A1, which is what we just solved for, so that'd be 2 times negative 1/3. That gives us negative 2/3. And then plus n minus 1. So 12 minus 1 is 11. 11 times D. So again, we need to distribute our 6 through, and that gives me negative 12 over 3 plus 66D. So now we're going to have to do some fraction addition here. I'm going to need to add 12/3 to both sides. To make this thirds, multiply on top and bottom by 3. So negative 330 over 3. That's the same thing as negative 110. I'm going to be adding 12/3 to that. And over here, I'll just have 66D. So when I do that, I'm going to get negative 318 over 3 equals 66D. And so then to solve, we divide both sides by 66. And you might just want to be doing this in your calculator if you don't want to do the fraction stuff out by hand. But up here, if you're by hand, if you're dividing by 66 over 1, it's the same as multiplying times 1 over 66. So you get this, and then you can divide top and bottom by 6, and that gives you your final answer then in reduced form for what D is here in this series. the next problem that I want to look at is number 23 from 7.3. And here we're dealing with geometric sequences and trying to find A1, which is again the beginning term, and this time R, which is the ratio between the terms. So a geometric sequence, you start with the term, and then each subsequent term is multiplied by a common ratio each time. In this example here, it's by 2, so each term gets twice as big as the previous term. So we're changing by multiplication from each term to term. So looking at our problem, we're going to need to look at a formula that connects A's and R's, and that's going to be pulled up in the chapter here with not really a specific formula for it, just the definition of a geometric sequence. We have a good example here. We're going to use the two terms that we know and what the definition of a geometric sequence is to figure out what R is first, and then that can tell us what A1 will be, the first term. And so by definition of our geometric sequence, we're starting here with A2. To get to A3, we would just multiply by R once. To get to A4, we would take this answer A3 and multiply by R again, which would give us R squared, and so on. A5, we would take whatever A4 is and multiply by R again. And so to get to A7, continuing this process, we would need to do R to the 5th power. And the difference between 7 and 2 is 5, so that's a quick way to get what your exponent needs to be. So our exponent needs to be to the 5th power times that common ratio, and we start with the value for A2. And when we do that, we get A to the 7. So this is A2 here. And then we get our 7th term in our series, and we're told what that is. So now let's just solve for R, and we'll have that common ratio. So divide both sides by -4, and that's going to give us the R to the 5th equals 32. And then you take the 5th root of both sides. Your calculator should be able to do that. You might have to raise it to an exponent of 1 over 5 as a fraction. You would want to make sure you put 1 over 5 in parentheses, so it raises it to 1/5 instead of raising it. If you don't use parentheses, a calculator might raise it to the 1st power and then divide the whole answer by 5 because it doesn't know that you want the 1/5 power. So make sure you use parentheses if you have to type it in like that in your calculator. But yeah, you could take 32, raise it to the 1/5, or your calculator might have a 5th root button. But either way, you're going to get the answer that R is equal to 2. So if R is equal to 2, that's one of our answers we want here, but we're also looking for the first term. Well, whatever our first term is, we multiply it by R just one time to get our second term. And we know now all these pieces, R is 2, and our second term is -4. So divide -4 by 2, and you're left with just the first term, which would be -2.